the key takeaway from this video is that energy cannot be created or destroyed. It can only be transferred between various forms and objects. This concept is fundamental to many parts of the physics curriculum. Today, we'll focus on the different forms energy can take, how it moves between those forms, and what is meant by work done. When energy is transferred into an object, it's stored in one of its energy stores. We explore each of these in detail in other videos, but for now, here's a brief overview. Thermal, or internal, energy is essentially the heat inside an object, linked to its temperature. Kinetic energy relates to an object's motion. Gravitational potential energy is based on an object's position within a gravitational field. Elastic potential energy refers to energy in stretched objects like springs. Chemical energy is stored within chemical bonds. Magnetic energy is what allows magnets to stick to surfaces like fridges. Electrostatic energy can give you a static shock when touching something like a car. Nuclear energy is released by splitting atoms. The important point is that energy in these stores is not permanent, it can shift from one store to another. Transfers can happen in different ways, through mechanical means, like stretching a band, electrically, such as plugging in a device, by heating, or by radiation, like sound or light waves. When we focus on an object or set of objects, we refer to it as a system. In physics, a system is simply a term for a collection of matter. When a system changes, energy moves, either between objects or among different forms. In an open system, energy and matter can be exchanged with the surroundings, meaning energy can enter or leave the system. So, an open system can either gain or lose energy. In contrast, a closed system is isolated from its surroundings. No energy or matter can flow in or out. While energy can still move within a closed system, the total energy remains constant. To see how this works, let's look at a couple of examples. Consider a kettle filled with water. When it's turned on, electrical energy from the outlet flows into the kettle's heating element. This energy is transferred electrically to the element's thermal store. In other words, the heating element gets hot. Then, the heating element passes that energy to the water's thermal energy store, eventually causing the water to boil. Another way to describe energy transfer is by using the term work done. There are two types you should be familiar with, mechanical and electrical. Mechanical work involves a force moving something, for instance, kicking a ball upward, where energy from your leg's chemical store moves into the ball's kinetic store. Electrical work happens when a current flows. You can think of it as energy used to overcome resistance in wires. A practical scenario: imagine a train approaching a broken bridge. The brakes apply friction to slow it down. This friction performs work by reducing the kinetic energy of the wheels and transferring it into thermal energy in the surroundings as heat, hopefully bringing the train to a halt.
If you haven't heard before, you can find all of our videos on our website geniushub.co.uk. Additionally, you'll also find MCQs, flashcards, past papers, and quizzes. Make sure to leave a like and subscribe for more content like this.